Okay, today we're going to be solving systems of equations by using substitution. Last week we did with graphing, so we're going to see similar problems, just this time instead of graphing, we're going to be solving it algebraically, so with equations. So I wrote out some steps, but pretty much you just want to make sure that you have at least one equation that has a variable by itself. It really doesn't matter which variable as long as you have a variable by itself. You then take that variable, plug it into your other equation, and solve it. So if I look, we're going to start off easier and work our way up to harder questions. So the first example, I know that y is 5. So I'm going to take this 5, plug it into my other equation so I can figure out what x is. So I get 2x plus 5 equals 25. I'm going to solve that, so subtract 5 from both sides. Get 2x equals 20. Divide by 2 to get x equals 10. Now since I already knew that y is 5 and I know x is 10, my coordinate is 10, 5. So if I were to graph this, they would intersect at 10, 5. Okay, number 2, this time I know what x equals, so I'm going to take that and plug it in right there. So I get 4 times negative 2 plus 2y equals 8. So I just rewrote the rest of the problem. So I get negative 8 plus 2y equals 8. Add 8 to both sides to get 2y equals 16. Then divide both sides by 2 to get y equals 8. And then I already knew that x equals negative 2, so it would intersect at negative 2, 8. Okay, we're going to get a little bit harder, where this time the variable by itself isn't just a plain number. It's a couple terms, so I'm going to take this 5x plus 1, plug it in for my y. So I get 4x plus this whole thing, so 5x plus 1 equals 10. 4x plus 5x is 9x plus 1 equals 10. Subtract 1 from both sides. 9x equals 9. Divide by 9 to get x equals 1. And then this time, we can take our x equals 1 and plug it into either equation, but it's going to be easier to plug into this first equation just because y is already by itself. So I'm going to plug it back into that first equation to get 5 times my x, which I found was 1, plus 1. So 5 times 1 is 5, plus 1 is 6, so y equals 6, which means my final answer would be 1, 6. Okay, number 4, doing the same thing. So I know y equals 4x plus 5, so I'm going to take that 4x plus 5 and plug it in right there. So we get 2x plus 4x plus 5 equals 17. 6x plus 5 equals 17. Subtract 5 from both sides to get 6x equals 12. Divide both sides by 6 to get x equals 2. So from there, I need to figure out what y is, so I'm going to plug it back into that first equation. So I get 4 times my x value, which was 2, plus 5. 4 times 2 is 8. 8 plus 5 is 13. So y equals 13. So the coordinate is 2, 13. Okay. I'm going to look at some similar questions. Number 5, it doesn't matter which way you plug it in. If y equals 3x minus 2, I'm going to plug it in, say right there. So we're actually putting the two equations equal to each other. So I like to start with the smallest variable, so I'm going to subtract 2x from both sides. 3x minus 2x is 1x, or just x, minus 2 equals negative 5. Add 2 to both sides to get x equals negative 3. So from here, I can take this negative 3 and plug it into either equation, so it really doesn't matter. Most people choose the first equation, so I'm just going to choose the first one. So we get 3 times our x, which was negative 3, minus 2. 3 times negative 3 is negative 9. Negative 9 minus 2 is negative 11. So your answer is negative 3, negative 11. Okay, number 6, this time I know that x equals y minus 2, so I'm going to take that and plug in for x. So I get 4 times y minus 2 plus y equals 2. We get 4y minus 8 plus y equals 2. 4y plus y is 5y minus 8 equals 2. Add 8 to both sides to get 5y equals 10. Divide both sides by 5. Y equals 2. So this time I need to figure out what my x is. So I'm going to plug into this first equation. So we get x equals y, which is 2, minus 2. So x is going to equal 0. So the coordinate is 0, 2. I'm going to move down to the last two questions. Okay, these two, we don't have a variable by itself, so we need to get the variable by itself. So you can pick whichever equation you want to do that with. But for this first example, number 7, it looks like it's going to be easiest to get y by itself for this first equation. So I'm going to subtract 2x to the other side to get y equals negative 2x plus 3. And this is what I'm going to plug in to this other equation. So we get 4x plus 4 times my y, which was negative 2x plus 3, equals 8. So we get 4x, 4 times negative 2x is negative 8x, 4 times 3 is 12, equals 8. Negative 4x plus 12 equals 8. Subtract 12 from both sides. Get negative 4x equals negative 4. And then divide both sides by negative 4 to get x equals 1. So then I'm going to take this, and again you can plug it into either equation, but I think it would be easiest to plug it into this new equation. So y equals negative 2 times your x value, which was 1, plus 3. So negative 2 times 1 is negative 2, plus 3 is 1. So your coordinate is going to be at 1, 1. Okay, one more. And again, you can choose whichever equation you want to get the variable by itself. I'm just going to do the first one. So when I move that negative 5x, or when I move that 5x to the other side, I get negative y equals negative 5x plus 5. But I don't want negative y, I want positive y. So I'm just going to change all my signs. So I get y equals 5x minus 5. So then I'm going to take that and plug it into this second equation. So negative x plus 3 times 5x minus 5 equals 13. Get negative x plus 15x minus 15 equals 13. Negative x plus 15x is going to give me 14x. Add 15 to both sides. Get 14x equals 28. Divide both sides by 14. Get x equals 2. So I'm going to take that, and again, you can plug it into whichever equation you want, but I think it'd be easiest to plug it into that new equation. So we get y equals 5x, so 5 times 2 minus 5. Oops. 5 times 2 is 10, minus 5 is 5. So your coordinate is going to be 2, 5. Okay. So if you have any questions, please let me know.